Sıradaki konuşmacımız Vertiv'den Kuts. Kendisini alkışlarınızla sahneye davet ediyorum.
Very much. Check, check. 1, 2, 3. Hope everybody hears me. Thank you, organizers, for inviting me to this event. Thank you, previous speaker, Mr. Domagoj, for making. I was actually surprised. You know, it's a very nice preparation for my presentation because now we're going to go deeper into the data center, into the white space. So I'm going to focus on what's actually happening inside and which technology we are now implementing all around the world. So just a few words about me. I'm a solution architect, so I'm making the concepts, the designs of the facilities for the greenfield, for the brownfield, and my focus is in the AI data centers. So you know that the technology develops very rapidly, so we are talking now about GB300 as an actual technology in terms of NVIDIA tech, but everybody wants Vera Rubin. Everybody is looking for the rack densities of 200 kilowatts and more, and I think that we have came up with a really great solution which, you know, like we called it one core. If somebody likes Lord of the Rings, it's like one ring to rule them all. So we were trying to go with the lower densities. We understand that some markets have the challenges, unlike the US, which are building 200 megawatts, 400 megawatts, the big facilities. And we were trying to start with the smallest possible capacity. And it was defined as a 5 megawatts. So we're gonna be talking today about 5 megawatt plus data centers, which are aligning in our one core technology. This is how it looks like. You may see it also at our stand. There's a lot of space for the explanations that can be done, but basically it's a hybrid data center which consists of the gray zone, which is modular, because I work for infrastructure solutions. We are aiming to prefabricate Vertiv equipment and something that is happening inside of the data hall. You see, it's pretty obvious that this is a flexible and modular solution because you can simply copy-paste it to the infinity. There is some limitations, but again, let's keep it simple. Nothing in tech is too hard to understand if you break it down. I would like to ask you to pay attention. There's going to be a small video where this picture is going to become live. And after that, I will pause and explain on every and each component. So this is how we see one core. It's a shell. We have the fan coil units inside. We're bringing them prefabricated on the skids. We have the structure to accommodate the bus bars, secondary fluid network, CDUs, rack if it's needed. Outside, we are putting the power modules with a medium voltage and a low voltage powertrain. We are providing the so-called service modules just to connect one thing to each other. And we have, of course, the hydro modules and the specially developed chillers, which we are calling trim coolers, which operate on very high temperature because the temperature regime inside of the secondary fluid network can be above 40 degrees Celsius. So that's a short video, just a teaser for you. And we will continue for each and every component. The simplest one is the data hall. It can be anything. If we're talking about the greenfield, it can be the steel structure, it can be deployed by a local company, it can be provided by Vertiv, our partners, but usually it's in the scope of the GEC because it requires some construction works. It can be a brick and mortar building, it can be anything. It just has to be a white space, it has to be clean and ready to accommodate the IT equipment. The next important thing is a power module. So we have the powertrain unit with a medium voltage or without a medium voltage. So basically it is sufficient that you have some level ground, you have the data hall prepared, and you have a substation to provide the medium voltage. So you see there's a transformer, there's RMU unit, and there is a UPS and some switchgear. Of course, the batteries and the cooling units for this equipment. It can be two types. On the screen you have seen the outside version. It's outdoor enclosure. It has a lot of the benefits, but also if you're planning to build a bigger data hall or a bigger building, you can use the indoor version, so-called skid. It will be just a platform with the switchgear, with the UPS. The benefit of this solution, it comes prefabricated, it comes pre-tested, so plug and play, mostly. What is special about the topology? The power topology has changed, let's say, dramatically. All the collocators and the hyperscalers, they used to have the block redundant topology. And for the most cases, it's more than enough. If you have A plus B feed, it's okay to use it, to have the STS switches, to have the UPSs, and to have the catcher UPS. It no longer works in the AI world, so we are basically making our topology based on distributed redundant. And for the one core solution, we have two types. It's 5 to make 4 or 4 to make 3 on the scale of the UPS systems. Of course, the power supplied to the AI equipment, to the IT equipment, is always 4 to make 3, as it's requested by NVIDIA, by AMD, and other vendors. A few words about the service modules and skids. This is something that allows the more easier and plug-and-play connection from the power modules, from the chillers to the IT hall. Again, it can be prefabricated as a skid. It can go inside of the building if you have sufficient space, or it can be supplied as an outdoor module and be a perimeter unit around your data hall. It's nothing but the pipes, the cables, some cooling units. You can potentially place a CDU there. We are experiencing some demands and some requirements from the customer that the cooling part should be separate from the IT part. We don't mind it, but keep in mind that still you need to put the SFN, the secondary fluid network, all the way to the server itself. This is what goes inside of the data hall. We're calling this SmartRun. SmartRun was developed specifically for the NVIDIA equipment. We started from GB200. It's an overhead structure, which is quite massive. So you see the height of the structure is more than 2 meters, basically more than the height of the rack itself. But there's a reason for it. We are accommodating the secondary fluid network. It's a steel piping. We are accommodating 4 busbar system. As I mentioned, the topology requires 4 to make 3. Each busbar can be rated 400 amps or even 800 amps, depends on the length of the structure. And also some cable trays, of course, connectivity. We cannot work without the connectivity. This is how the secondary fluid network looks like. It's steel pipes. This is how the SmartRun looks in the real life. The biggest demand now, of course, in the US market. This is something that allows faster deployment, that allows longer time to prepare the data hall itself, because if you will just supply all the components on site versus the prefabricated ones, you will have the less time, the smaller window to prepare the site, to make it the real white space without the dust, without the other workers interfering during deployment. So this is the solution that can basically fit any data hall, and we're using it in the one core solution. And also it can be modified for the part of the storage and network racks, because It is based on NVIDIA SuperPod design, but we also have some other racks on site, MMR rooms, etc. And we can use this kind of a technology to feed and to cool the racks which are normal density up to, let's say, 30 kilowatts with A plus B distribution system. What goes outside is two types of the chillers. We are dividing the cooling loop into two. That's reasonable, and we are chasing the efficiency as a secondary fluid network, and the the temperature regime in the water-cooled servers is closer to the 40 degrees. We're using the separate loop and using the chiller that is operating on 40 degrees temperature of the supply, water or the glycol mix. This unit is a recent development of Vertiv. The benefit of this unit and the special design, it's basically larger. It has embedded pumps, so it means that you do not need to oversize your hydro module to accommodate all the pumps. And in the end of this unit you see the water tanks. So it's also a part of the prefabrication. The platform that has the test tanks usually to provide the 3 minutes of autonomy time, because while we have this switching period from the grid to the genset, we need to keep the system up and running, because the CDUs need to pump the water, the chiller pumps need to operate, and it means we need to provide the continuous cooling, not because we are trying to reach like tier 4 as Uptime Institute, but because we have to, because the equipment will overheat and it will cause a lot of problems. The monitoring platform. Usually in this kind of the presentation, everybody leaves it in the end and says it's kind of an optional thing and you shouldn't really worry about the monitoring because still on the equipment you have the interfaces, you have the dry contacts, you have the open protocols, and you can do it as you like. But it's not really like this in the AI world, because there's a lot of stuff that is mandatory for the operation of the data center. So the SCADA system needs to have special algorithm, not only to warn the dispatchers and the service personnel that something is wrong, but it really needs to be proactive. And we are combining it with a leak detection system with the valves that are operating on the secondary fluid network. So just a simple example, if we have the leakage of the secondary fluid network near some server rack, we are initiating the shutdown of this server rack, the software shutdown, and after the system is sure that server is shut down, only then we are closing the valves, because otherwise, again, the server can overheat and it can cause problems and even damage of the equipment. Talking, again, let's zoom out. Talking about the specific solution that we are currently manufacturing and deploying. It is one core for the GB300 GPUs of NVIDIA. It's a 12.5 megawatt data center. You can see the footprint. It accommodates up to 236 racks, and the footprint requires around 1,500 square meters. Potentially, the space can be optimized, because the technology of the prefabrication and working with the steel allows to place components on the 2 stories, even on the 3 stories. Potentially we can put the chillers on the top of the power modules. We can put the generators, again, maybe on the top of the power modules, but it usually requires the additional investment, and all the facilities that we are working with, if it's a greenfield, we're advising to start from the one level, because it's less investments, better let's say, serviceability, and the topology is basically the same. We are currently looking forward to expand our portfolio based on the one core technology. Everybody now is looking for the AI factories. Even though the AI factories, it is something very application specific. So, for example, I'm solution architect for Vertiv. If you are building the AI factory together with NVIDIA, if you're a customer, you will be assigned the solution architect from NVIDIA. So they are going to tell you which equipment to use, how to position this equipment, which limitations you have on the connectivity side of this equipment, and it is very important because, for example, the two main limitations is 100 meters of the cabling point to point inside of the superpod. Nothing critical because superpod is quite a, let's say, dense environment. But another limitation is 500 meters from the core to the leaf. So basically from the point of the network rack which is inside of the core part to every server rack which you have in the superpods, you should not be more than 500 meters, and it gives some challenges when we're talking about the 50 megawatt, 100 megawatt, and bigger data centers. This is something that we have already designed as the standard, let's say, as a standard approach, as a reference design that we are going to share, I believe, next month. So please stay tuned. We are going to announce it on every platforms, you know where to find us. And now we are looking forward up to 1 gigawatt AI factory. The technology, the approach, the scalability is going to be the same. The selection of equipment, some new announces, stay tuned, it's going to be different and it's going to be interesting because as AI is evolving, as the technology is going denser, we are trying to keep up and I believe doing a good job in it. So speaking about AI factory, you see the main characteristics. Its solution is very similar. Yeah, there is some differences inside of the data hall of how it is organized, and specifically there is one core data hall that should be in the middle of the data center itself. But again, it's a very challenging journey with every customer, with a consultant and a partner to settle all the things and to start designing the actual data center. And we are trying to, and we are doing this, we are helping the customer to understand which power demand do they need on their plot, what topology to pursue according to their demand from the application perspective and from the IT topology perspective. The budgeting part is something that can be solved relatively quickly with a reference design, so the customer can understand and present to his stakeholder that, look, if we're going to build the AI factory on this land, we will have to spend this budget, but the return of investment will happen in 1 year or so. So yes, just a few words about our team. So we have a team of the solution architects, we have a teams of the pre-sales engineer and design engineers. On each step of the project development, we are going to be engaged with you, with your customers, with your consultants. We have something to advise, but also we have something to learn because we know that some customers have a different requirements, and of course we are aligning with them and offering them the solutions that are not actually the part of the reference design. And it's fine. It's AI race is a race, but still a journey for everybody. And it would be very nice to have some journey with you in Istanbul, in Turkey. And thank you for your attention. If you will have any questions, you're welcome to visit us in our stand, and I think we're going to have the round table, right, in a few hours. We're going to have the round table discussion, right?
Yes, yes.
It's 4 p.m.
Yes.
Great. Everybody is welcome to join the discussion as well. Thank you.